we planned, but we ultimately put it on the DSP processor and what was on ASIC and GPP. So currently in CARE we are developing the software defined radio, and where we have multiple DSPs, ASICs, FPGAs, and the same problem. And so you're solving the same problem where this is one of the boards we have with an FPGA and the digital signal processor, and we are mapping things here and there. There are things which we are doing on GPP, then there are things which we are doing on DSP processor. Sorry, this slide is not working, but primarily so you need to decide once you are implementing the system what goes on DSPs, FPGAs, and programmable processor. This is yet another project which we did earlier, and here it was a very interesting system. It was a passive navigation system. We put it on a flying object, and the flying object is looking down. It has a video camera in it, so it is taking a real video, and then the platform also stores all the satellite imagery of the area. So in real time the system can locate itself, without any GPS. So with doing image processing techniques, the bird is flying, it's looking down, and it knows where it is. By just looking down, doing pattern matching, where it takes the video, then it searches for that piece of the clip or the frame in a satellite map, and it maps it, and it just keeps doing it on one frame. It's like this is the position, it finds itself here, then this is the position, it finds itself here, this is the position, it finds itself here. So it basically it knows where it is. There was another system which requires us to do a lot of signal processing, and the system, once we were designing from the scratch, we had two boards. On one we had the FPGAs, two of these FPGAs, and the other one was another FPGA and the DSP processor. And then we have another system which we did spectrum analysis, primarily done everything on the FPGA, and this is a communication receiver. So this brings me to really the last slide. And then I'll spend a little time in just going over the grading policies and what I expect from you to do in this course, and you already know what you are up to. So advancement in VLSI technology has enabled engineers to develop products and solutions to complex engineering problems. And it's very different. These skills are different than the software skills, and very different, and not many people have these skills. Honestly, you hardly find people having these skills, because maybe of many reasons, because it's difficult to learn. It's not, and not many people are actually perhaps are getting into this torture. Digital designs are, but for me it's really fun to exercise. The algorithms are mapped using digital design techniques that exploit multi-layers of parallelism. FPGA technology is very handy and can be put to use for devising innovative solutions. And this brings me to the course. So in the course, again, if I just recap what I have said, but it's just an introduction to what you are going to see in this course. We'll go step by step. Okay, we'll spend time learning Verilog, though most of you perhaps must be knowing Verilog already, but still we'll go quickly cover Verilog, and then we'll get into the converting algorithms, MATLAB or maybe C to fixed point, and then actually spending time in designing the top level architecture. And after we do that, and then we get inside the blocks, that all the design options, at least you need to know that how to do parallel designs, how to do dedicated designs, how to do timeshare design, what are the techniques which can automatically help you to do these designings, and then the state machines and the micro-coded state machines, designing your own processors. And I'll be taking few quizzes, and they will not be surprised. I'll tell you before I take a quiz. Whenever we complete a major milestone in the course, we will have a quiz, so that it help you to prepare for the next stage of the assessment. There will definitely be few labs assignments which I would like people to do alone, so that you learn. Again, as course obviously is different. It's a hands-on course. Unless you sit down and work, you will not because just like programming, unless you do it, you cannot just learn it from the books. So you got to actually sit down, do most of these assignments will be in Verilog. So I'll expect you to do these assignments alone. You can take help by just consulting each other, but not copying, the assignments. But then projects can be done in a team. So you can do it alone if you want to. You can team up with other people, 1 to 3 students, and these projects, because this is an advanced course, there are several advanced topics which we will learn. The techniques, the unfolding techniques, the folding transformation, the C-slow techniques. So we'll see. The book has actually written in a way that it covers the undergraduate and also the postgraduate. So we'll spending more time and emphasis on the advanced stuff, but covering quickly the basic things. I don't know currently whether we are taking 1 sessional or 2 sessional. Depends if the case is only taking once, we'll take 1. Otherwise, we'll take 2 sessionals, and then the final exam. As you see, there is some tolerance in the grading, because it depends how good projects you do, whether and how many labs assignments I give you. So I'll just adjust it accordingly. Maybe if there are more assignments I've given you, will increase the weightage of the assignments to 15%, because mostly it's hands-on. In the final exam, I expect people to actually do the designing. I expect people to do the coding there, and then usually I ask people to copy the code and then code it actually on the machines, actually simulate it and then submit the code. So because it's again a hands-on course, so I expect people to design things and actually then to make it work. And for that you have days you can have 2-3 days design something there. There may be mistakes which you commit while writing code in the exam, but then you can take the same code home and then you can just make it work. For your own comfort and for knowing that whatever you have designed actually also works. So this is all about the course, and if you have any questions, I'll be very glad to answer. And book, try to read it. It's a good material to read. So as I have shown you, this is the pirated version, and this perhaps I'll put 1 copy in the library, so you will have both, but you can always also download it from the internet. Just type in the title and you will find several sites where they are hosting this book, so just download it. But I think a hard copy is important, because that help you to actually read it. So कोई सवाल हो किसी का तो जी. बुक का जो नाम है वो है डिजिटल डिज़ाइन ऑफ सिग्नल प्रोसेसिंग सिस्टम्स, अ प्रैक्टिकल अप्रोच. So this is the book name. So digital design of signal processing systems, and then there is this is a book on Verilog, and this is another book which is more hardware focused, more Verilog examples, and by this book select. ठीक है, questions? Okay. जी please.
Sir, being a mentor of PS and being like my mentor as well, sir, I have something in my mind that usually in university abroad there is something done that a project or task is assigned to people that you do this in this whole course, and you just represent it or implement it and you bring it to me, and that is his whole course. Because if he goes through that, then it's the whole course he has understood. So my intention of attending this course, I am into this thing, that my intention is that if I do this course, at least I go through such a thing that I can implement something and I bring up, and that should be my overall result or my overall assessment of the course. So that's a perspective that I want to share.
No, there are like design courses where just there is only one design, but I'm not sure if in this course, but if honestly there are people, because I taught this course for years, and there are people who would do just excellent work and they publish things, and I know many like पूरा MS का thesis कर लेते हैं इसी course में, जिनको they are really too much into this, and especially the people who are actually working in and different organizations, they do amazing work in their projects. और वैसे ही आपको अगर if you already know this, तो paper में तो वही होगा, you know. But this is something which I can look at, like crafting it in a way that you do the assignments and assignment makes into a bigger project and a bigger project makes into even something bigger. I'll try कि इस तरह से कुछ हम बना सकें, हो सकता है। मतलब आप अगर स्पेशली जो थीसिस ऑप्शन के साथ कुछ करना चाहते हैं, आप इसको इस तरह से देख सकते हैं। फॉर एग्जांपल इसमें होगा ये कि यू टेक एन एप्लीकेशन एंड मैप इट इन हार्डवेयर, सो यू गो स्टेप बाय स्टेप। आप एप्लीकेशन ले लें, आई कैन गिव यू दिस फ्लेक्सिबिलिटी दैट वंस लर्निंग अबाउट कोडिंग थिंग्स इन सी, टेकिंग एन एप्लीकेशन एंड ऑलरेडी कोड, लेट्स से you want to work on neural networks, for example, आप कहें I want to make this chip which does the back propagation neural network, or I want to do this chip which does the routing, for example, the router is the router, the forwarding engine, जो भी whatever you are up to. So you can just start thinking के your special interest in case or in your master is this particular subject. ऐसे में your interest is in pattern recognition. And you say, अच्छा क्योंकि मैं you should intend to even work on pattern recognition, so you select any application of your interest. ज़ाहिर है कंप्यूटर इंजीनियरिंग कर रहे हैं, कोई तो इंटरेस्ट होगा, नेटवर्क से लेकर कम्युनिकेशन से लेकर सिक्योरिटी से लेकर any interest you have. So we start from there. You say you take, and some of you, not all of you, but if like some of you wants to do that, I'm fine with it. So the first assignment we do will be the conversion, like writing C code, converting it into something which can be implemented in hardware. So you do that exercise instead of doing the assignment. You do that exercise. फिर हम आएंगे representations, that how you represent an algorithm graphically so that you can map. आप उसी प्रॉब्लम को वो कर लें. So you are moving step by step and also gaining experience that actually how should you actually design these things. Next step is कि जी RTL design है. अब interestingly एक चीज़ है application. There are different ways you can actually scan the whole spectrum of design techniques. For example, मैं आपको कहता हूँ it's a pattern recognition. ठीक है, हमने बहुत सारी pattern recognition की problem solve की हैं. It depends के how intensive the problem is of pattern recognition. Let's say you are doing one fingerprint in 1 second. It's a simple problem. So you do unfolding. You design something which should take minimum area. You are doing encryption, for example, AES कर रहे हैं, simple encryption, but your maximum data rate is 2 megabit per second. ये एक architecture बनेगा. AES algorithm is same, but there you will try to make it very small. Then you are doing something which requires 10 megabit per second. Then you are doing 40 megabit per second. Then you are doing 10 gigabit per second. You know, it's a whole spectrum of architecture of the same application. So then what you can do is, as we learn these techniques, you say, I will select an architecture. AES is a good example. FEC is another example. Pattern matching is another example. I can just give you examples कि आप उसी को लेके चलते जाएं आगे. And you say कि जी routing is a good example. ठीक है, आप कहें जी routing है, एक कौन सा router बनाना है. And then you just go through these steps. And device जब folding पढ़ रहे हैं तो fold कर दें उसे, unfold कर रहे हैं तो उसको ही unfold कर दें. और इस तरह करते करते you then do your project and वो जो लोग हैं वो फिर honestly इसमें कम से कम अगर पेपर वगैरह आप पब्लिश करना चाहें, it'll be very easy for you to actually publish your work in, because architecture हर एक का unique होता है. It's like architecture of a house. It's not standard, you know. It's your imagination how you are actually crafting it. So क्योंकि मुख्तलिफ होता है तो you can always present it. There's something your own, is your creativity, and then you can just take it and write it a paper and something like that. तो इस तरह से कुछ कर सकते हैं, लेकिन फिर भी फाइनल एग्जाम होगा. सही है. ओके जी, थैंक यू वेरी मच. ये प्रेजेंटेशन आपको वेबसाइट से ही मिल जाएगी, सो यू कैन जस्ट